Number 5 was like a 180-degree rotation around that point. Right? So I see if this is my pre-image, this is my image. I'm taking this triangle and I'm turning it all the way around that point 2 times, which would mean that angle V is congruent to angle L. I guess here, actually, you know what? Let's say angle UVW is congruent to angle WLU. This little guy here, LWU is congruent to VUW. And then angle UWV is congruent to WUL. That makes my head hurt. Did you guys just do single letters? You did, right?
Yeah.
Okay, that's fine.
We did double and single letters.
Double letters and single letters?
Yeah.
Oh, yeah, for the lines, double. Yeah, obviously. I'm talking about for the angles. You guys just did single letters? Okay. With the proofs that we're going to get into today, we're going to do triple letters. I know I did single letters yesterday. I realized after the fact that it doesn't make sense because is U this angle, is U this angle, is U the whole angle? It can't be all three, right? So we're going to, from this point going forward, we're going to use the three letter names for angles, okay? What about my side lengths? UV. What is congruent to UV? You guys did it, right? WL. Good. Can I say LW here? No. What about UL? UL is congruent to what? WV. Thank you. And finally, UW is congruent to WU. Great job. All right. What about the back side? Anything on the back that we need cleared up? Yeah, Alex? 11. Awesome. 11's a great one. What else? Yeah, Ava? 16. Perfect. What else? Chloe? 17. Great. All right, let's take a look at 11. So what do these two triangles have in common in number 11? Do they have any sides in common? Yeah, how many sides do they have in common?
2 sides.
They have 2. They got this double marker and then they got this triple marker. Do they have any angles in common? No. So all we have is SS. Is that one of our congruency theorems, just SS? No. So can we say definitively that these two triangles are congruent? No. We have not enough info. Like we said in our notes, sometimes that's going to be the answer. I cannot tell if these two are congruent. If I was asked to write a proof for these two triangles being congruent, I wouldn't have enough information to do so, right? I'm sensing a similar thing that's going to happen on number 16. What do these two triangles have in common? Yeah, Alex?
They have all 3 angles.
All 3 angles are in common. Well, they must be congruent then, right?
No.
By the AAA theorem? Triple A? Is that a thing?
No.
No.
No, not really.
Right? Tyler, question?
Could you do number 17?
We're doing that one next. Christian?
12.
Wait, what's happening right now? I thought we're still talking about this one.
Sorry.
So again, AAA is not one of our theorems. Not enough info for that one. 17. Is this side the only thing we have in common? No. What else do we have in common? Angles. Which angles? The vertical angles. So this is what? Side angle or angle side as? Is that one of our?
No.
No, it's not. Not enough info. Are any of these congruent? Well, Christian says 12. Let's look at 12. I've got these triple measures. I've got these double measures. Are those the only congruencies I have here?
No.
No. What else is congruent?
Right angle.
The right angle. All right angles are congruent with each other. So I've got a side with an angle in between and then another side. Well, which congruency theorem is that? Side, angle, side. Can I call this SSA? Is that the same thing? No. Can I call it ASS? No, we definitely talked about not calling it that, especially not out loud. This is side, angle, side. Right? The order that we write it, much like when we're writing a congruency statement for the triangles, the order has to match up. So a side and then an angle and then a side. But if I have something like number 10, I have an angle and then another angle and then a side. Angle, angle, side. Yeah, Tyler?
But number 15, would it be angle, angle side, or angle side angle?
Number 15, I've got these angles in common. Obviously, my vertical angles are in common. And I've got this side, angle, angle, side.
You did like left to right? You know, like a certain way.
Are you saying, can I write it as side, angle, angle?
No, like, is there a certain way to read
Is
like
there,
the
is there like a
diagram?
certain way to read it? Instead of like getting angle side angle, you get angle side?
It depends on it's determined by where the side is. Here, the angle that's congruent is in between the two sides. So in the name, the angle is between the two sides. You see that? Over here, my angles are together, and then my side is off to the side. So angle, angle, side.
Okay.
Does that make sense, or did I confuse you more?
I think that makes
Tyler, what do you think?
So,
Still a little confusing?
because like, I can't tell the difference between angle side angle and angle side.
Perfect. Are there any ones on here that is angle, side, angle?
18.
18?
I think it's angle side angle. I'm not
Yeah, it
sure.
is. But,
I'm glad you brought that up. 18. Let's see. I've got my angle here. I've got my vertical angles there. And I've got my side. Now, what you guys are saying is that we're confused. There's two angles in common and a side. So is it angle, angle, side? Or is it angle, side, angle? Give me a thumbs up if you think it's angle, angle, side. Thumbs down if you think it's angle, side, angle. What do you guys think?
Whatever.
Our thumbs should be up. This is angle, angle, side. Who can explain why this is angle, angle, side? No one? We just know it is. Liana?
Because the two triangles aren't connected by the side, they're connected by the angle.
I love that thought. That doesn't technically justify why it's angle, angle, side, but I love that thought. You're definitely not wrong about saying that, Tristan.
The side is not in, the congruent side is not in between the two congruent angles.
That's all it is, right? This side is not between the angles. Now, if these were congruent, right? Let's say these ones aren't. If these were congruent, then it's angle, side, angle, because the side's in between the congruent angles. If it's off to the side, then it's angle, angle, side. Great explanation, Tristan. Thank you.
I think that makes sense.
Does that make a little more sense, Tyler?
Yeah.
Okay. We're just looking at where is it at, right? Here, right, there's two sides in common and an angle in common. Well, can I call that angle, side, side? No, because where's the angle? In between the sides. So when I write the theorem, my angle has to be in between the sides. Side, angle, side. We're never going to have angle, side, side. Right? Like we talked about. And we're going to see in a second why that is not a possible congruency theorem with a nice little visual that I found to support our learning that I did not make.